let's see. We good? Levels? Yes. All right. Hey, welcome back for another week of hacking on some Haskell projects. I am your host tonight, Agent Ultra. Welcome to my stream. Thanks for watching. It's nice to see you. So, what are we working on? If this is your first time tuning in, I typically work in Haskell on this stream, and we build stuff. You know, because people say like Haskell's like an academic language. It's not very practical for building real software, and we build all kinds of real software here. And our latest project is this game called Lambda Trek. It's a clone of an old school game, a very old school game called Star Trek or Super Trek, or one of its many, many, many variants. The idea is that this little S is us, it's our ship. We're a starship of some kind, and we're trying to repel the forces that have invaded our local bit of the galaxy and destroy these like, little ships here denoted by these carrots at the moment. There's less than sign. We also have stars. You would do this by inputting your commands here, like move, like 3, 7, say 3, 8. We move our ship around like that, right? And we can fire our phasers. We give it a certain amount of energy. Right. We hit our enemy, depletes our energy. We hit the enemy for something. And, yeah. So I think there was something going on with this still. Yeah, we don't have that much energy, that's good. But I noticed the 0 was kind of weirdness out. Well, that one worked pretty well. 23. Okay, cool. Maybe I was wrong about this. Anywho, there you go. We hit the enemy for a bunch of damage. And now I think this week we gotta implement destroying the enemies. And yeah, we need like still manual phaser fire and like torpedoes. We need to implement space stations of some kind for refueling our energy. We also need to implement like all kinds of things. So running out of energy, our own shields, things like that. Cool. Oh, we also wanted to do kind of like not numbers exactly for the combat dialogue there. So we should probably do that too. Okay. Let's get rocking and rolling. Our code, projects, Lambda Trek, bang. Yeah, we did quite a bit of work on updating the calculation of the enemy phaser damage. Rubber barrel. Super good. Let's open up our combat simulation module. Okay. So the combat dialogue. That one's pretty good, but what we have in there right now is more debuggy type stuff. It might be useful to have a way to keep this in here, though, so that we could flip it around if we ever needed to tweak the numbers a little bit. Have like a debug mode would be super cool. I know there's a way to do something like that with preprocessor macros, but I've never really used them all that much. what's HPPP? HPP. It's designed as a library and an executable. So, oh, this is a cool little library. So, I guess this is one way we could use it, do it. Blah. We can have this little HPPP thing, and we can pass our debug flag, and then like we want to debug build, so that we can like view the actual numbers and not the other text. That'd be super useful. I wonder if this is what everybody uses. I actually don't know. We have a language extension CPP. Okay. Right. So this is basically, I think, how most libraries do it. Because mostly we use a GHC these days in Haskell land. Mostly. So we could have a little debugging flag here. I wonder if Stack has this built in. Haskell. Maybe we should look at the user guide. Find out. A little diversion here. A useful one. CPP preprocessor. We don't need a custom preprocessor. How do we do? Let's Google around a little more. Google. We want Haskell Stack preprocessor. There's a Stack Overflow question. Is it possible to use CPP process as the Haskell stack? Blah blah blah. Flags. Oh, okay, cool. So we should be able to do it like that. Awesome. So we add compile language CPP. And we can have two different implementations here based on the flag. We have to have debug. else. And if. Okay, so what do we want to do for generating the dialogue? Let's see if this works first. I'm gonna output something completely weird. Preprocessor macros might not play nicely with linting. Which will be unfortunate, but for the greater good. Can we do Lambda track here? I didn't rebuild anything, so it's going to do that. Build. Yeah, there we go. Well, it's going to build and optimize one. Ooh, it is going to do that too. Warnings. Okay, that we already did that. Beep. Okay, cool. And if we do stack build flags, we have to give it a target, I think. Lambda track debug. No, was what it GHC dash flag dash flag. Package Lambda track not found. Is it Lambda track like this, our package? No. That doesn't seem to work. Oh, we have to define flags. Okay. Okay. Cool. So like this. Okay, package name, flag name. Debug. Comme ça, maybe like that. Key manual not present. Nope. Flags. Okay, how do we do this? Okay. Yeah, just like that, right? That's what we have. Oh, I'd have to put it in like a library stanza or something, maybe? Or maybe in, I don't know, the executable one? Maybe where it was fine. We just don't need the command line option? No. Okay, I don't know. Maybe we'll mess around with that another time. Let's get back on track. So at least we'll figure out how to set that at some point. I guess maybe we could just kind of leave it there, hopefully, and it'll just, once I figure out how to use it, it'll work. But yeah, you can use the C++ preprocessor on Haskell source code for this kind of reason. Mostly, like, make your libraries backwards compatible with older versions of the compiler. We're going to use it for, like, debug, maybe. And we're going to work on the generate command dialog. So let's see. We want to have, like, if it's, I guess, like a small amount, like gradations, I guess, would be the thing. We could have, like, if it's too much, not much damage at all. Not much damage. We might say, like, we barely damage the enemy ship. Minimal damage, sir. Might be like our response there. Light damage. We might say we hit the enemy ship. And then we say, like, medium damage. We scored, there's a direct hit. Heavy damage. The enemy has taken a heavy blow, Captain. Okay. I think those are pretty good gradations. Maybe we can come up with some variations on this, but I think this is a good start. We'll look at the amount. That'll be easy enough. Say, we do with guards. Amount is less than 20. We could just say minimal damage, sir. This side will be an equal sign there. But if it's greater than 20, but it's less than say 30. We'll call that light damage. If it's greater than 30, but not greater than 50, we'll call that medium damage. And if it's greater than 50, we'll call that heavy damage. And hopefully this builds. Yep. Let's try running it. Let's go close to the enemy. Fire our phasers. Minimal damage, sir. A direct hit. I'm not gonna have enough energy to do. Well, I don't think we actually limited. 50. We don't have that much energy, yeah. Do 40. Direct hit again. Okay, we have to reset. So that's the general idea. Phasers 45. Phasers 50. There. Done. Still a little bit concerned about that 0 we were seeing on the first hit on the enemy, but maybe that's just a. I wonder if that's just a fluke or if there's something wrong with our calculations still. Let's see, we get a factor, shield damage. Oh, right. We were taking away the shield damage, so it wasn't actually hitting anything. But we should do 0. We should do something for 0. No damage. Weapons did not make contact. Yeah, something like that. Some punctuation on there. If the amount is less than or equal to 0, that's what we'll do. We should have our builder running. That's what we should do. Cool. So, by the way, if this is your first time tuning in and you're not familiar with Haskell or anything like that, that's okay. I love answering questions, so please feel free to hop in if you have any. I am all good with that. I like diversions. Okay, so that I'm gonna get the builder running so we can run this continuously. In fact, I'm gonna use the test runner to do the building with fast and file watch, just so we can keep this going. Oh, I'm in the wrong place on this one. Let's see, projects, Lambda trick. Okay. That's good. Okay, so let's test for ship destruction, right? If we destroy the ship, what happens? Okay, so if we apply damage to any enemies in our sector, and those enemies' hit points are less than or equal to 0, we should flag the ship to be destroyed. Let's go to sector. Yeah, so we keep the enemy ships in an array. Should probably do the same thing for stars. So an array is like a fixed size, something that gets allocated once and is pretty static. So we're not going to like pop the enemy off or anything. We're going to keep that enemy in there. I think we should just add a flag to the enemy record. Alright, because we can't have... Sometimes in Haskell we want to have like nicer types to represent state better, so that we can't represent state that should be technically impossible in our program. And one way to really mess that up is to use Boolean flags. But we could use we could use a function to calculate whether the enemy is destroyed or not. Or we could use something like maybe some sort of type to represent the state, destroyed or not. Let's try a function first and see how that feels. Is destroyed. I mean, looks pretty harmless. We'll use record wildcards to pull that out. And all we need to know is if enemy hit points are less than or equal to 0. So I'll have to add that language extension. Okay, so now that we know that enemy is destroyed, when we filter for damaged enemies in the automatic fire, enemies, and get enemies in phaser range, we need to update that to not consider enemies that are destroyed. Enemies in range. Okay, so this is where we can convert the array to a list, so we can use filter. This would be a pretty good place to put this as well. But then we'll be doing the box calculation for each enemy, if they're destroyed or not. Or, no, we'd be filtering them first, actually. Yeah. So we could do that there. That would be fine. So filter. Let's see. It's the association list. We take the second element of the tuple, which should be the enemy, for our filter function. Oh, yeah. Enemy in range wants to have the enemy as well. Maybe we just put this over here. That's already a bool. We need to combine these two things over the enemy. Is there such a function? Let's search Google. Something we can compare as equal. I have an A to bool and another function A to bool. And I have an A. Can I get a bool? Quite a few. Patterns. Or maybe a list of such functions. Yeah. I mean, that's basically, I guess we're going to have to write our own. It's not too hard to do. So we basically want to have these in a list. And this to be like all. Oh, I probably have data.list in scope? Maybe? No? Okay, so all shouldn't be a problem here. Bring that over there, just tidy this up a little bit. Oh, now I got a name clash here. This is not the all that you think it is. I'm going to call it all P. Okay, it's not defined. That's good. Okay, so Lambda track. We're going to need, I guess, a module for that. We'll call it Lambda track list HS. All P. So we have an EQ. I don't think we need the EQ constraint on this. We just need a list of functions. A to bool. So on A, return a bool. Okay. Okay, so if we have all P, the empty list, nothing to check, and it doesn't matter what we have, we can just say, sure, it's true. Okay. Otherwise, we have some predicate and more predicates to test, and we have our input value, and so we want to check if the predicate on X is true, and all P on the rest of the predicates of X. The syntax isn't right. Yeah, it should be P of P's. That. Okay. So then we just need to import it here. And the track list, all P. Okay, so now they just need to be functions of the same type, enemy to bool. Okay. Should probably have a new test case for that too. Just to make sure that works. Probably does, but I'm trying to be good about this. Do we have enemies in range? We do. Okay. It should not return destroyed enemies. can add a destroyed enemy. Example enemies with destroyed. Sample destroyed enemies. That'll be fun. We'll add enemy at 2-2 with 0 hit points. 0. On example enemies. Example destroyed enemies would be, and it should be this example here. Just bring that over a little bit. Oh, right, it's not a list. It has to be an array. Okay. In which case, we'll just have to construct our own. Okay. And that test should fail if I make this a 1, right? I suspect it will. It doesn't. Well, that's a problem. Am I using the wrong field? Nope. XY, XY, 0, 0 to 8, 8. Standing at 2, 2 should be in range. Example destroyed enemies in range. Yeah, that's right. If I make this 3, that should fail it. Yep, it does. And that's what we want. Well, maybe we don't want not on there. Brr. Maybe that's what we want. Beep, beep, beep. Aha. Okay, well, we broke the other test, so it's not right, but this little bit, at least for this particular case here, we got it to change. So it's filtering out everybody. So we do want not is destroyed. And just double check what we did for the implementation of is destroyed. Enemy hit points less than or equal to 0. Okay. So this, I expect it to fail in this case because we have 3 enemies. All with health, all in range. And yet, we only say it should be these 2. When really, it should be this. That should make it pass. But this is going to make it fail then. Is all P maybe the problem here? Could be. I think the test is right. It's gotta be something else. It's gotta be all P. Yeah. Yeah, it's gotta be all P. I think it might be short-circuiting on something. Maybe. Let's check list here. We can't evaluate the conjunction here until we know all the values for all the predicates after they've been evaluated. So I don't know that that's really the problem. Let's see. Greater than 3 and less than 10. It's true. If we do 11, it's false. False. 2, 3, 4. Alright, so that seems about right. And what else is there involved in here? Range box corner. Enemy in range. The problem. What if we make this enemy 1 as well, for example. Exactly the same as the other one. So it should be in range. Still. Oh! It's the list array arguments. That's what it is. That's what it is. My bad. Okay. There we go. That's not the failure I wanted, but here we go. This will pass, but if I change this to 1 now, it'll fail. That's what it was. It was Haskell preventing us from, like, shooting ourselves in the foot with arrays. And me just being dumb about it. Okay, there we go. We only expected these 2, but we got a 3rd. If we change that back to destroyed, as in 0, that should be good. There we go. Okay. What do we change here? This, yeah. Okay, stage everything. Add a commit. Update. Enemies in range. Don't consider destroyed enemies. Enemies are destroyed when their hit points go below, equal to or below 0. Boom. Okay, that's one part. And the next thing we need to do, we need to remove destroyed enemies from the map and not show them. So we're gonna do that in the UI. Actually, I was just thinking, it's great and all that we filtered it out with enemies in range, but I'm wondering if the better way to do this is when we get the enemies from the sector. If we have a function for doing it that does the filtering for us. That might prevent us from making more, like, forgetting to do that filtering. But game-wise, I'm not really sure it makes a huge deal, because maybe there might be commands where, and I haven't decided this yet, whether we want to be able to target wreckages. You know? So, I'm going to leave that for now. And yeah, let's just go on to the UI part. Lambda track, UI. It's our UI module. So we're using Brick as the library for generating this nice terminal UI for us as we're building kind of this prototype of the game. So Brick, super handy, very useful, very nice. I like it. An example of a pretty good looking and pretty useful declarative UI. Similar, like, I think Brick came before Monomer, of course, but Monomer is fairly recent, but Monomer follows the same path too, and I like it. It's nice. So we're gonna go to sector display and sector build tiles. That's what we want to look at. Build sector tiles is going to go into all the sector data and generate a tile map for us to render. So here we also need to filter out is destroyed from enemy ships. So we have this add enemy function. We only really need to do it when the enemy is not destroyed. So let's add a little guard here. Otherwise, unsafe set tile, that's fine. But if is destroyed enemy, then we don't have to do anything. We can just return the tiles untouched. Yeah. And so we could just run that. We can go now over to our enemy. Sorry, 7-3 phasers, 90. Ooh, weapons did not make contact, sir. That's not quite the message we were expecting, but it did remove the enemy from space there. So we might have to update the move command now, because the helm's still reporting that the enemy ship is there. But we could change that so that Helm reports that there's a damaged enemy there. Or a destroyed ship. We could do that. That would be cool. Let's make a tile for that then. Let's go enemy position X. Enemy position Y. We'll call the tile destroyed enemy ship. Let's move that of that. So we don't have destroyed enemy ship yet. We have to define that. I believe it's a tile. Destroyed enemy ship. How do we want to represent that? It looks kind of like a wreckage. Like an explosion. That looks like an explosion, actually. There you go. Okay. So, now if we do that, we should see a blown up ship. It's destroyed. Okay. So if the enemy ship is destroyed and it renders that way, let's commit that. That's good. So when applied, this change will render destroyed enemy ships. What else do we need? We need to update that helm message. The move for the move command. And handle move. This collides with enemies. So here was where we would need to change that a little bit. We can inspect the enemy. But instead of collides with enemy returning a boolean, we should return a collision. Let's see, how do we want to represent that? We could do something like... almost like a maybe. Yeah, I could probably just use a maybe there. Make this a maybe enemy. Hey, Count Torin. I'm great. I'm fantastic. How are you? Long time no see, I think. So, let's see. We have collides with enemies now, or the array elements. So array elements converts to a list. I think we can just take the first just value that collides on enemy. I think we have something like that in data maybe and data.maybe. No, we might need it. So, that's fine. Yeah, so instead of bool, we're going to return maybe enemy. And we're going to have to change this function to find maybe. We might have to write that function. So I'm going to call it find maybe. And then find maybe is going to return that first collides with enemy. So I don't think we need to case match on it. Okay, now assuming we can implement find maybe, I think this will all work. We're trying to find a good way to develop mobile with Haskell. Okay, so do you mean like a backend for a mobile application, or like Haskell running on iOS or Android? Haskell running on iOS or Android. Okay. I don't have any good recommendations there because I've never done it before. Running natively? Would be interesting if you could get like a Cocoa interop to work. Well, still, and it's all built with Nix. Yeah, that's pretty sweet. Cool. Yeah, when we were doing like game development and stuff. Obviously, one of the questions that comes up is like cross-platformness, right? Can I get a Haskell application to run on like a Switch, a Nintendo Switch or something? And I guess my thinking there is that you'd have to probably port the Haskell runtime or some kind of runtime and compile to it. But for platforms like iOS and stuff where you have like a web view, you know, it might work. Yeah. A static link cross-compile Haskell program with Nix. Yeah, it could be. It depends, I guess, on the hardware platform. If GHC can compile code for whatever's, I don't even know what is in the Switch, but that's just one of those examples that comes up. PlayStation 5, I think, is a pretty standard processor, isn't it? Yeah, an AMD Zen 2. So nothing too crazy. So Haskell should be pretty easy to port there and get to running. And was the Xbox Series X is the latest one there? Yeah, what's the processor on that one? Probably a standard Intel or something, I bet. Maybe an AMD. Oh, it's a custom AMD, is it too? As well? Huh. So it might be super easy once you hit one to get the other one. As long as the instruction sets are roughly the same. And GHC targets this platform. That's cool. So, like, I think it's seriously possible. I've been thinking about this a little bit. That, like, serious game dev ought to be possible in a functional programming language. I think the only thing that really holds it back is the time and energy required to build like a serious engine. But like a special purpose engine, you should be able to do it. And the porting, I guess, would be the other thing. To do one on PC, it's been done already, so there you go. Yeah, so I don't know. I think it should be possible. I think it should be possible to do like a high performance game engine, even in Haskell. But it's just a theory. Because, like, okay, well, the reason why I think this is that a big bottleneck for a lot of game engines these days is, like, the memory architecture. So, like, laying out your memory in structures that make sure that everything you're processing is all processed together, so you avoid all those cache misses, because those like take up a huge amount of time. And you want to like schedule if you're doing like 3D stuff with like OpenGL or various other graphics drivers, you want to schedule your like data, uploading your data to the graphic card to be as infrequent as possible, but still sufficient for like getting all your data in there so you can render things properly, which I think Haskell would be really good for. Right, and then like processing the runtime input stuff with Haskell's like built-in parallelism primitives would be really dope. I don't think laziness would be too much of a problem there. There's probably a few places where you need to be strict, and there might be like a couple of places where you just do need that really tight mutable loop, but I think you should be able to compile that from Haskell to like a C extension and just compile that along with your artifact and link it along with your artifact and get it going that way. But it would be a fair amount of work to get to that point where you can show something impressive, for sure. So find maybe. We're gonna write it like this. This is gonna be a list of maybe A's. And we're gonna turn a maybe A. The first one we find, basically. Right, so if we have the empty list, nothing. And yeah, F sharp. Yeah, you can do Haskell for the web now is slowly coming along. Should be getting pretty good real soon. I think the only thing that's lacking really is the tooling, the front end tooling, to get it to actually run in the browser. I did a couple of streams where I tried to get WASM going. So the Haskell compiler compiling to WASM works great. Getting that WASM module to run in the front end, not so great. I haven't figured out how to do that. And that's mainly because, like, front end tooling, I'm just not up to date with it. I don't know what's going on. I'm not experienced enough, and it's not really well documented. It's kind of bleeding edge type stuff. So hopefully it'll come along soon enough where dum-dums like me can get it to go, and that'll be super sweet. Because there's some cool stuff I want to do with that. So we have just something. But if it's a just, whatever it is, and other stuff, then return X. What's the problem here? Oh, I'm missing an underscore. And what did I do here? Oh, right. We have to update lines with enemy to be maybe enemy, not just bool. Right, so we can check here, we can guard here if is destroyed enemy. And obviously we don't comply. Otherwise, we have to check. And we return that, wrap that up in a just. No. No, this becomes our guard condition. That's happy. Alright, so if it collides, if the enemy is destroyed, it's nothing. Otherwise, if this guard is true, just enemy. Otherwise, nothing. These are kind of redundant. So we could just add enemy dot is or not enemy dot is destroyed enemy I have to put those in parentheses probably, and there. Alright. What's that? What's Plutus Cardano? Well, it's a smart contract platform. Okay. Cool, cool. Is that a Haskell thing too? Probably. Probably. Oh, Plutus is the native smart contract language for a top. It is written in Haskell. Okay. Effectively Haskell programs. I got it. Alright. Nifty. Super cool. So the reason why this is not a worky is because I maybe here, yeah, I don't have the right type for this. This should be A to maybe A. Data maybe. Okay, so that's all good. Adpex Twindong, what is going on? Welcome to the chat. One of the only companies in industry that prove the code by proving that the code is equal to the math papers. I guess. I mean, that's kind of what smart contracts do, right? But it's not the only company doing, like, verification, if that's what you mean. Right. I have some... This is, like, kind of an area I would love to work in, but I just don't have the research background to justify it, getting hired to do it. So I'm mostly like self-taught in it, but I do have some friends who are working on things like fully verified hypervisors. And so my colleague spends most of his time and most of his days writing proofs using interactive theorem provers and proving properties about this hypervisor that they're building that is supposed to like keep applications that are maybe not like fully securable in the same level, but giving it the same level of security by running them inside the hypervisor. And so you kind of like jail them inside this hypervisor. And then you get things like making sure the hypervisor can't share, it's impossible for the hypervisor to share memory, and for processes running inside of it to leak information and all these sorts of things. Yeah, it sounds super cool and a lot of fun. Okay, so now we have the type problem here because this is no longer a Boolean, it's a maybe, so we have to They use Coq, I think, with the Isabel or Iris, the separation logic framework. So they do a lot of their proofs in this. Because they're working with the implementation languages in C++. And separation logic is really, really built and really good for writing proofs about programs that manipulate state by allocating objects on a heap. You can represent that pretty well in separation logic. Yeah. Oh, you huge. It's the best way. I mean, I've done some stuff in Lean, and I kind of enjoy it. And I like a little bit of Agda here and there. I've tried it. It tickles a part of my brain that it enjoys being tickled. But, like, I still do a ton of programming in Haskell just because it's, as fun as it is, it's just a lot more practical, even though it's not quite there. You know? You can still get a long way with Haskell just fine. So yeah, this is a pattern match now, not a Boolean, which is nicer. So if we have just... we can put like E here as the enemy we can bind. The else case becomes nothing. And if we just ignore E for now, this should compile again, and we should be able to run and get the same behavior we had before. Only now we can change the dialog. So if we try to collide with the destroyed enemy ship, then we can start changing the message there. I fire the phasers, full blast, bang, destroyed. We have 8-3. We can't. Oh, we can now. I think we're on top of it now. Yes. So our collision detection is not preventing us from moving in there. Right. Okay. That makes sense. That's the way it should work, actually, based on this definition here. Because if we look at the guard here, collision detection is done where the enemy is not destroyed. And when the enemy is destroyed, we're just going to go right to this branch here, which means that we're not colliding with an enemy anymore. So we can move into that space. And so we do. So we want to prevent that case. So I actually don't want is destroyed here, I guess. In either case where we're colliding with an enemy, we want to collide with it. We just want to change the message. And maybe like some of the behavior for other commands, but for the move command, we just want to change the message. We just want to say like something different and not move in there still. So I'm going to remove that condition there. Maybe move this back here. Yeah, still. Okay. Okay. So now we can destroy the ship. Fire them phases. Alright, destroyed ship. Now if we try to move into space, it says we'll collide with it directly with the enemy ship. we should change that message to be like, we'll collide directly with ship debris. So is destroyed E. Add something. Otherwise, the regular one. Yeah. Okay, just cut that, plop that over there. With the enemy ship instead of the inner ship, with volatile ship debris. And we don't need that. Yeah. Sick. Alright, we destroy that poor sucker. We try to move into the space, but, oh, Captain, we would collide directly with a volatile ship debris at blah blah blah. Looks good. Like it. Let's just get rid of that extra space. And then let's commit it. Oh, let's clean up our warnings, though. Get rid of that. Okay. Boom. Boom. So we update handle move, engine move. We check for destroyed enemy ships. And report a different message. Okay. And I wanted to fix that weird kind of bug where we destroy that ship right off the hop, but it's showing a weird unexpected message. Might have noticed it. So we go here, here, and we fire phasers. Boom, destroy it. It says, weapons do not make contact, sir. That's not true. Fortunately, I think the fix for this is quite simple. It's less than or equals 0. Oops. Bug. I made a whoopsie. And that should be gone. Destroyed that sucker. All right. Energy. Okay. We should probably also add a message if the ship is actually destroyed. They took a heavy hit, and if they're destroyed, we should be like, oh geez, we destroyed them. Oh geez, Captain. Oh, heil. Okay, so firing automatic. So in phaser damage results, we get the enemy. We can check if they are destroyed and say something different. Phaser damage report enemy. So we're going to say instead Enemy ship destroyed, Captain. Sick. Okay, there we go. Let's destroy that sucker. Boom, enemy ship destroyed, Captain. We're good. Well, that takes care of that story. So now we can destroy enemy ships. It shows up in our UI as debris. We leave the debris behind. We could use the debris for other stuff as we develop the game. We get cool combat log messages that are just a little bit nicer than pure numbers, at least for combat. And yeah. And then the enemy ship destroyed message. I like it. So when applied, this change will add the enemy ship destroyed message. Dialogue, I should say. Dialogue. Because that's what it is. Okay, we've only got a few minutes left on this stream for tonight, friends. It's coming to a close. Let's see, what else? We need to also have the game over state happen, right? With the enemy, when we run out of energy, we should be adrift. That's the usual game over state for a game of Trek. So, if we were going to handle this, we can go to update simulation. We could check after updating the simulation. We can check here. Where else can we do this? Probably in the main loop. In app. Alright, so handle event is where we get the form state of the input, command input. Return an error to command. Once we get a command, we modify the game state by running that command. And so we could also, once we finish updating the state, check for the game over in the updated state and see what we get, and if we have to switch to a game over state. So let's first add our, let's check our state. Right. Let's see. If we want to start adding the game over screen, that's like a completely different UI. We could maybe switch over to that somehow. Or we could have a flag in here. Again, I'm not a huge fan of flags, but that's one way of doing it. We could do like game state over, game over. Boolean. But we could be smarter about this. We could not do a Boolean. We could do an enum. What would it be called? Game screen? Game screen could be main game screen? Main? Ooh, actually, this is a good point. This is a good thing to do because we're going to also want a different UI for the warp screen. So the first one should be sector screen. We'll have a game over screen. EQ, bounded, enum, EQ, and show. So this is like an enumerant type. These type classes just kind of add some functions for working with enums, so we can translate enums from their indices back to their constructors and things like that, which makes serializing these a little bit more efficient and whatever. Things like that and of that nature. I'll just make it a little bit more clear what its purpose is. So we could do game state screen. Game screen there. So we create the initial game state. We'll initialize that as, well, what we've been currently doing, which is just a sector screen. That should compile, and nothing else is really using that yet or interrogating that value, so no problems there. Okay, so when we handle the command, we modify the state. We can check the state to see if it is game over yet. I wonder if I could do like this. Is game like a function? It is game over. What else can we do? Yeah, that seems fine. If it is game over, I want to do something else here. My spidey sense is tingling. Like, I want to get the game screen. No, game overs is checking the state. Yeah, I kind of do want to do this. Yeah, is game over. I'm thinking about the wrong thing here at the moment. Then we want to switch the game screen. So we want to do a modify here. Another modify. Something else. Don't do anything else. Don't worry about it. Alright, because of indentation, it thinks that's a function application. Applying. You have to modify it to you. That's not. Okay, so is game over is not defined. That should be our type error at the moment. Yes. It is. That's what we want. Okay, is game over. I'm just going to say is game over int. It's not what it is, but hopefully GHC will tell me what the type of that should be, and then I can just plop it in there. Well, obviously it just wants it to be a bool. But we need more than that. Yeah, no, this isn't right. That's not gonna work. Yeah. How about this? Grab that. Format it better. And suppose we could implement a function like that with that type. Then this whole just needs to be a function like that. And update form state and update simulation. Game state to game state. Yes. Oh, we want the modified game state. I think what we can do here is we can refactor this to use lenses, and that'll just make it easier to pull out the part that we want in order to check game over. But unfortunately, we're just out of time tonight, so we'll have to get to that next week. So I'm not gonna save the file. I'll save the file. Whatever. I'm just gonna throw out this code here. It's fine. Not this code though. Just this part. And yeah, and then we'll get to this next week. So there we go. Stage that. Create a commit. Add a game screen to game state. This will be used to control the UI state, etc. Thanks, Zarak, for tuning in, and everyone else. ApexTwin.ng, Apex Twin, Aphex Twin, whatever. All good stuff. Hopefully I'm saying that all right. Countorin, everybody else, it's been a pleasure. I do these streams, if this is your first time tuning in, I do these streams once a week on Tuesday evenings usually. You can follow my schedule here on Twitch, or, you know, hit those buttons that follow the thing and create the notifications if you like that instead. Also pretty handy way of doing things. All of the code that you've seen tonight is available on GitHub, free of charge. It's on GitHub at Agent Ultra. That's this guy right here at Lambda Truck. Okay? So you can get it there, star, like, whatever you want, hack around, mess around. I am also on the Fediverse. You can follow me here on the Types.pl server at Agent Ultra. And if you're in a different time zone, you're watching on my YouTube channel, you know what to do there as well. Thanks again for tuning in. Go to this link above too. We have a Discord server here with a channel just for the stream, as well as channels for other cool streamers who are doing programming languages like Haskell, other than Haskell, whatever. Everyone's pretty cool there. So you should check that out. And it's been a slice. Happy hacking out there, and may your monads always be free and your types always check, and I'll see you next time.